Yes, Vignesh, tell me about yourself. You're muted.
Hello,
Hmm.
hello. Am I audible
Yes.
now? First of all, good afternoon, everyone. Thank you for giving me this opportunity to introduce myself. My name is Dandeka Vignesh. I have previously worked as graduate engineer trainee at Business Private Limited at MIDC Supa, Ahmedabad, Maharashtra, and graduated from VNT Nagpur, BTech in Chemical Engineering in the year 2023, having a CGPA of 8.99. And I have done quite few projects in my graduation. My final year project include synthesis of bioplastics from bio-waste materials like banana peel and orange peel. And also I've been part of many projects like study of methane extraction from natural gas hydrates and benzyl alcohol manufacturing plant schematics. And also, other than academics, I have also been part of extracurriculars where I have served as alumni secretary of chemical engineering department at PNA, where I have organized meetings with various alumnus, with students, and also provided few internships through the alumni contacts. And other than that, I have also been as event manager for an event at Axis 2024, which is a technical fest. So I have been event manager for Space Innovation Challenge, where I got to manage a group of people for event, and we have successfully conducted the event with minimal possible chaos. And my hobbies include watching cricket, playing cricket, and a bit of cooking, and also in my leisure time, listen songs.
Okay, just tell me what is distillation.
Distillation. Basically, distillation is a mass transfer operation where we separate components based on their relative volatility. Like if A and B are involved, so we'll be separating component. If A is more volatile, then we'll be getting that as the overhead product and B as the lower head product using the heat,
Using?
using heat. I
Using.
mean, because based on relative volatility, we'll be separating A and B.
What is the driving force in distillation?
The driving force in distillation is obviously the boiling point of A and B.
Hmm.
So the more the difference in the easier would be the separation.
Can you tell me about relative volatility? How can you define relative volatility? And how is it related to distillation? You said as the difference is boiling point, right? I don't think so. I think so.
Yes,
It's
sir.
volatility.
So like I mean to say is that if a component is more volatile, it is having a lesser boiling point. So
Hmm.
in that sense, I want to put that way.
Hmm.
So obviously the reason for separation is relative volatility, which is obviously the vapor pressure of A. If I consider A and B, it is vapor pressure of A upon vapor pressure of B.
So it is something like ratio of vapor. You are saying that it's ratio of vapor pressure of A upon vapor pressure of A to vapor pressure of B, right? That is PA saturation,
Yes, sir.
PB saturation, right?
Yeah, yes, sir.
Suppose in that case, if I have not been provided with the saturation pressures of A and B, then how I can calculate the relative volatility? Uh,
Uh, if
Instead, in spite of that, I have been provided with mole fractions, mole fractions of A and B as well as total pressures.
so, since the mole fractions are provided for liquid fractions, so with the help of the relation, like we have the relation like total pressure is equal to partial into XA plus partial pressure of B into XB. We have got this from Raoult's law, derivation of Raoult's law, and also from
Okay.
uh, the relation like partial pressure of A plus partial pressure of B is
You
equal
are
to
making
total
it,
pressure.
why you are making the simple statement to a drastic statement? It's so simple, right? It's so simple. You said PS saturation upon PB saturation. Fine. The answer was so
Yes,
simple.
sir.
Sir, from Raul, the answer should
Okay,
be,
okay,
don't be nervous. Don't be nervous. Okay.
okay, sir.
Feel, feel as usual you feel, right? Okay.
Okay, sir.
The thing is,
So like,
but wait, let me answer. You must
okay,
say,
sir.
you must say, sir, from Raoult's law, the Raoult's law state that P total is equals to Xa into PA saturation, right? If I have been provided with Xa and total pressure, so P saturation will be Pa upon Xa. Sir, may I write and derive? You could have said that. Okay.
Okay, sir.
So that must be answer. Okay. Pa upon Xa
Okay,
upon
sir.
Pb upon Xb.
Yes,
Fine.
sir.
So take it simple and easy. Don't take it so rigorous. Fine.
Okay,
Over.
sir.
Okay. The next question over to you. How many types of distillations are there?
So distillations can be classified in three ways, like simple distillation, flash distillation, and distillation with rectification.
Hmm.
Uh, and also we can there is also like a few other distillations like extractor distillation and steam distillation, where the in a steam distillation we use steam as the medium for separating A and B. Uh, in case if if we go like if the boiling points if the materials are heat sensitive, we go for steam distillation so that at lower boiling points we can separate them. Like if the boiling point of the liquid is some around 80 degrees, we can separate it below that only using steam in steam distillation. And in extractive distillation, that is involved with unit operations and unit processes both combined, where extraction and distillation are the things happening in extractive distillation.
I think we forgot about azeotropic distillation, right?
Yeah, sorry, sir. Sorry to forget that. Yeah,
And
there is
they
an
are not,
also
and
other
the
type of.
distillations are not of three types, right? And the distillations are not of three types, Vignesh.
Okay, sir.
Okay. You said, may I count or you will be counting?
Uh, as far as no, I can
One is
recall
simple,
only
one
the
is simple distillation, which you study
flash.
basically gate oriented. I'm talking about that things only. One is simple
Mhm.
distillation, another is open or steam distillation. Third one is rectification or fractional distillation. Fourth is extractive distillation. Fifth is azeotropic distillation. Sixth is multi-component distillation. Right?
Yes, sir.
This you don't study for gate purpose.
Yeah, but I have classified in a wrong way. That's the thing.
Okay, no problem. Okay, just tell me, is distillation process a steady process or unsteady process?
Uh, sorry, sir. I don't have the idea about that.
It's very easy question. What do you mean by steady and unsteady?
So steady process is where there is no accumulation
What?
happening.
Please
Steady,
speak louder.
steady process is where there is no accumulation of any quantity is going there. So whatever
How
the
can you
input,
relate steady? How can you relate steady process with time and space?
or to say in simpler manner, the properties are not changing with respect to
Hmm.
in steady state. Whereas unsteady, the properties will be changing with time.
Changing with time, right?
Yes.
Now compare steady and unsteady with distillation.
Uh, in that case, distillation would be steady process because always the uh, output would be the same. I mean, the fractions would be the same irrespective of the time. So I feel it is a steady state operation.
Fine, fine. Okay, just tell me about minimum reflux ratio. What is that? Why do we use it? And when do we use it? When do we use it? Not why do we use it? When do we use it? What is minimum reflux
So,
ratio? When do we use it?
so this basically when we talk about the reflex ratio, there are three cases. I mean, one is the total reflux, and the other is the minimum reflux, and the next one is the critical reflux. So when you asked about the minimum reflex ratio, that is it is the ratio of liquid that is going into the column after once it is get condensed and upon the distillate that is coming out from the condenser. So that it is nothing but a ratio of L by D, where L is going into the column again to interact with the vapors, and D is nothing but the overhead product we are getting. That is the amount.
I didn't ask you about reflux, right? There is major difference between reflux and minimum reflux ratio. I asked you not
Yes,
minimum
sir.
reflux.
Yes,
I
sir.
asked you
I'm going.
reflux
I
ratio.
was going step by step. Yes, sir.
So don't
So the
elongate
minimum.
the answer. First of all, don't
Okay,
elongate the answer. What I asked you about minimum reflux ratio. So you be stick to the point on the minimum reflux ratio only. Don't take me towards the reflux ratio. I know that, right? I'm well aware. What I'm asking you, just
okay,
tell
sir.
me.
So minimum reflex ratio is a condition where there are infinite number of trays.
Hmm.
So that is minimum reflex ratio. And
Hmm.
so can you please repeat the other part of the question?
I said, what is minimum reflux ratio? And second question was, when do we use it? Do we use it at total reflux condition?
No, sir. We use it at condition where we'll be having infinite number of trays. So at that condition, we'll be having minimum reflex ratio.
So, okay, fine. At total reflux, at total reflux, suppose there is total reflux. So, in that case, what about stages? Will it be infinite or minimum?
So yeah, we will be having minimum number of ideal trays,
Minimum number of
ideal stages.
ideal stages, right? And what about condenser
Yes.
duty and reboiler duty? What about that? Will it be maximum or minimum?
Condenser duty is like how much heat that has been exchanged between the vapors coming from the over
Just
top of
don't
the.
go into that. Just tell me, will it be maximum or will it be minimum?
In
This
what case, sir?
in total reflux case only.
So in total ratio, it would be maximum because since the minimum number of plates are there and also the reflex ratio is very high, so more amount of load goes on condenser and as well as on the heat reboiler, so it would be maximum. We
Fine,
require greater
fine, fine,
diameter
fine,
of
fine, fine, fine.
condenser only.
Fine. Okay. I'm stopping your recording. Vignesh, I think so. You need more practice, right? You are having the conceptual knowledge, but you are elongating the answers. The first point. Don't elongate the answer. The answers which are been required by the interview, just stick to that point only. The second point is what you are doing. You know that you are having conceptual knowledge, but you are not expressing or delivering it because of lack, because of more fear. You are nervous, quite nervous. You have to overcome this fear and nervousness, then only you are going to crack the interviews. Otherwise, conceptual knowledge to you are having just I was asking you basic question, but you got stuck in the basic question itself. It felt to me like it felt me like you are a little bit confused and you have studied more and you are not explaining the basics things even. Okay, the concept so you are having, right, but there is the thing you have to deliver, and I mean to say you have to express it in the right format, in the right form. That is because of your nervousness, your answers were not coming. I hope in the second interview you are going to do well and better. Fine. Okay. Hello. Any questions you have with
Sir,
me?
you unmuted me.
No, I
Sir,
didn't. Go ahead.
uh,
Any
sir, like
question?
you said, like there was nervousness. So any other improvement other than
No,
nervousness?
you don't need any other. You just need practice, right? Fine. And because of your nervousness, your interview was not good. That's why I took it somewhat big. And I go through distillation. Distillation is going to be asked frequently, and that is the most important topic, right?
Yes, sir.
And okay.